All right, welcome back everyone. This is Noah again, and in this video we're looking at the solution to the now you try problem, where we're given a rational function and being asked to graph it and say some things about what's going on with the scenario, evaluate that graph, answer a few questions. Specifically the scenario that we're looking at is that we have a population of deer in a forest that could be modeled by the function p of x equals 720x plus 2,310, all divided by 3x plus 7, where x is the number of years into the future. So the p is the population of deer, and x, the input, so the output is the population. Output. And the input is time in years. We're going to go ahead and graph this function using GeoGebra, and then we're going to answer how many deer live in the forest this year at time 0, right? And then how many deer will live in this forest in 27 years? When will the deer population be 247? Let's fix that little typo there. And then as time goes on, what does the deer population level out to? All right, so to start this, let's go ahead and do the graph like it asked for. Let's kind of try to make some sense of what this graph is saying, just generally speaking, before even trying to answer any questions. Okay. Let's go ahead and put this in over here. We've got p of x equals, we got a fraction, 720x plus 2,310 over 3x plus 7. Let's take a look here. Let's also notice that this is a rational function. The top and bottom are both polynomials. Specifically, they're linear, right? So a linear function is a kind of polynomial. The previous one that we did, there was a quadratic in one of them. But here we just have a linear over a linear. This is a rational function. I want to zoom out. This 2,310 is telling me things are going to be pretty big, so I'm going to zoom out in just the y direction until I get something. There we go. All right, let's actually look at the negatives also. For our scenario, we only want to look at positive deer population, right? As time, or I'm sorry, we don't want to have negative deer, but we also just want to look at positive time. This is modeling what's going on after this moment in time. But generally, if we look at this function, it's got this weird behavior where it's going like down, 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 down here, but then if I come from the other direction, it's going up, up, up. And this, if I type in x equals negative 7 divided by 3, we'll actually see exactly where that's happening. That negative 7 over 3, that's the domain restriction for this function. We'll talk about that more in coming videos. And then also, there seems to be this like horizontal thing that's going on here. I'll change something like this. This vertical line here, this dotted line, this is called a vertical asymptote. And we'll be talking more about those. And then looks like we've got, is that going to be at 4 at y equals 240. We've got this horizontal line, and it looks like our blue line, our populations are decreasing, but they're not decreasing to 0. They're decreasing to whatever this orange line is. That's 240. I'll go ahead and make that dotted as well. The reason I make it dotted is to point out that it's not actually part of the function. It's just a kind of a guiding line. It kind of tells us how the function is working without actually being part of the function itself. This we call a horizontal asymptote because it's sideways. This is a vertical asymptote because it's going up and down. And now we can really just focus in on what's going on with this deer population in the positive time world here. Okay. Just exaggerate this a little bit. Okay, there we go. Let's go ahead and take a screenshot so I can draw on this. All right. So the first question that we're asked is, how many deer live in the forest this year? So when x is 0, how many deer live in the forest right now? That's when x equals 0. So I'll say p of 0, and this is going to be 0 plus 2,310 over 0 plus 7. So we take 2,310 and divide it by 7. And what are we going to get here? It looks like 335. I'll just double check this. I think it's 335, and I'm looking at the graph. It looks like it's hitting 330 rather. Hitting right in between there. And if I get out a calculator here, just 2310 divided by 7, we get 330. There we go, and we can see that point on the graph. This is the point 0, 330. So we can say, right now, there are 330 deer in the forest. Next question, how many deer will live in the forest in 27 years? Now that's off outside of where I've graphed here, but that's okay. We can find that with the function. We can say p of 27. We can plug 27 in for x, and we'll get 720 times 27 plus 2,310. We can divide all of that by 3 times 27 plus 7. And let's definitely get the calculator out for this one again. For that last computation, we have a division, 720 times 27 plus 2,310 over 3 times 27 plus 7. And let's go ahead and get an approximation. That's about 247, right? And we're not going to have partial deer, so we'll say this is just 247. And we can say in 27 years, there will be 247 deer in the forest. And it's kind of interesting. When will the deer population be 247? Well, we just answered that, right? It's in 27 years. I don't know that that was meant to be that. Let's change this a little bit. When will the deer population, just because it'd be nice to kind of see some more out of this, when will the deer population be 280? And for this, I'm going to go back to that graph. So I'm going to say I have our graph 280 for the number of deer is happening right around here. If I type in y equals 280, and then I look for this intersection right here. This is happening at 2.9 years. So we can write that out. In 2.9 years, the deer population will be 280. Finally, we ask, as time goes on, what does the deer population level out to? And I know I drew in this orange line for us, and we can see that that population is coming down to it a little bit here. Let's go back to our graph once again and just kind of confirm that that's really what it's coming down to, because there's this gap, right? So as I zoom out, we'll notice that it keeps getting closer and closer to that orange line, but it never crosses it. I can keep moving to the right for forever. Here we're at 160 some odd years, and it still hasn't dropped below that. As I zoom in, it sure has gotten close. Like if I look at, it's not going to just let me grab points along here. But as I move to the right more and more, it's getting closer and closer without ever touching it. So that's just a confirmation that that's really what's happening. And that's how we tell, is we just kind of keep scrolling to the right and we can see that that's what that population is dropping down towards. And there is a way of computing that, and we're not going to learn that this term. We're just kind of looking at what is a rational function and can we look at the graph to determine that. For now, in the next class, in Math 111, then we look at how to find that horizontal asymptote symbolically, and so that we can answer that question without actually looking at the graph. And that's actually a really important topic in calculus as well, if anyone plans on going that far into their math career. So I can now say the deer population is decreasing towards 240 deer as time goes on. And that's it. So we've answered all of the questions and answered an extra question there just for posterity's sake to kind of see how we can tell when a population is going to be reached from the graph there. So yeah, that's it for this video. Thank you everyone for watching, and I will see you soon. Take care now.